Alright, give this one a go, see what you can make of her. I'm going to solve it now. When you start looking at this problem for the first time, you're probably going to be a little confused because it's like there's variables over here, there's x's over here, there's no real way to get an easy dy dx, right? And you're dealing with two variables too, whereas a lot of times, you know, you're only dealing with like the y's or the x's. But in this case, you're dealing with two variables. So in a problem like this, you have to know that you're going to be using partial derivatives to get your answer. So first thing I'm going to do is I'll move over this sign value minus sine y. And since we're looking for ultimately a derivative with respect to x, I'm going to take the partial derivative of this whole entire equation. So we will do d dx of all of these values here. My mic might be dropping out, but I'm going to keep doing this anyway, just in case. This will be d dx of 0. So let's start taking the derivatives. Well, this is going to be 0, right? I'll just bring that down there. That's simple. This first derivative, you may be tempted to just take 2x and then not do anything else. 2xy, and then not do anything else. But you have to remember that this y has to be treated as a variable. So you're actually going to do a product rule of this first term. So you're going to have d dx of x squared y plus d dx of x squared. Put those there. X squared d dx of y. Okay, minus the derivative with respect to x of, well, I'll just draw them all out. Maybe that makes it easier. E to 2x, and then the derivative with respect to x of sine y. So the derivative with respect to x of x squared would be 2x y, right? Plus x squared. This is where things get tricky, right? Because you have the derivative with respect to x of a y value. And again, you may want to call this 0, but you can't, because this is a variable. You can't treat it as a constant like that. So what you have to do is you have to use the chain rule to switch around your your derivative. So what we'll do, I'll do this in like a side note in red. We will say we're looking for some partial derivative of x, right? This is f, some function f, which in our case is y, a y value. Now we need it to be in respect to y to get a true derivative of it, right? So we'll say df dx is equal to df with respect to y. And then how do we get it back to this form? Because that's originally where we're at. What we need, well, you'd have to put a dy dx. And you can kind of see, like, these aren't really fractions, but you can kind of pretend they're fractions, if that makes sense. So if you were to cancel out these y's, you'd be left back with your df dx, right? So what does that mean for this situation? Well, you would have your x squared, and then you'd have the derivative with respect to y, which would be 1, right? And then you would also have to have this dy dx. So you'd have, I'll just write this out, dy with respect to y, the derivative of y with respect to y, and then you'd have to multiply that by dy dx. You're just using substitution. This is df dx, this is all that stuff. So let me erase this now. Actually, yeah, I'll just erase part of it. I'll put it over here. So I kind of want to keep that up as like a note. And then this one's easy. It's just a derivative with respect to x. You just bring a 2 out, right? And then minus derivative of x with sine y. Well, you're going to have to do the same thing again, right? So you're going to have a negative cosine of y, because you're taking this this partial derivative of y, and then you're going to be left with the dy dx. And that's all going to be set to 0. So the next thing we can do is move over our 2x and our negative 2e to the 2x, move that over to the other side. So we'll have x squared. The derivative of this y is just going to be 1, so we'll just have a dy dx. We'll have the next thing we'll have is this cosine y dy dx. And then we will subtract over negative 2xy. We will add the 2e to the 2x. Man, I can't fucking say that. So now we can factor out our dy dx. X squared minus cos y equal negative 2xy plus 2e to the 2x. And then we will divide by our quantity. And that would be your answer. It's a little bit of a tricky problem, but it ultimately comes down to using this chain rule, and then you'll be left with the dy dx value that you want. You factor it out, solve.